Okay. There. I thought I aligned this beforehand, but oh well. Should be good to go now. So, I had abruptly ended my stream yesterday, but hopefully there'll be no interruptions today. But shortly after, I did finish placing the last, 3 parts that were missing. Reflowed it, and then put in all the THT parts through all soldering. What residue? But I did plug it in and test it. Its I2C address is X6B. So it's responding to the bus, which is nice. And I did test plugging it in. It does indeed work. It was charging at 120 milliamps default, just straight off the bat. I'm hoping that's what it's supposed to be set for, because the sense resistors are allowed to be either 5 milliohms or 10 milliohms. At 5 milliohms, this board, well, the IC is supposed to be capable of doing 16 amps. With the 10 milliohms, you get better resolution, but 8 amps capability, which I don't need anywhere near 8 amps, let alone 16. It's also why this inductor is massively large, because this is spec'd if you want it to do 16, but I wanted to be safe about it and follow their reference designs as much as I could. I will have to dig through the spec sheet. I'm hoping that on power up it's monitoring these sense resistors to decide if it thinks that they're 5 or 10, but I'll have to dig through the spec sheet to find out. But, so that's working, which I'm happy so far with. It's going to be fun getting code to work on it, though. As I've explained, I'm not the best programmer, and I definitely haven't written an I2C library before, so that will be fun. Today's task is the BMS board. It needs to be assembled. It is the last of the 5 boards. I already have my stencil ready. I'm gonna go digging through some parts before I go pasting. Oh, my screen's also arrived for the BMS, for the MCU board. However, the screen likes to sit wonky. So I'm thinking I might cut some copper, similar to this magnet wire, but I have a thicker gauge around here somewhere. I might cut some of that and solder a peg to keep these aligned, because I'm fairly certain just staring at the screen like this all the time is going to drive me nuts. And then the other thing I'm hoping to do on this stream that I didn't get to do yesterday was I want to show this working, because I can actually fully operate this. The code on it is I think the most complete code I have, but it does need some changes, but I want to show this working. And Which way does this go? That way. Cool. That's got a bit of a bow to it. Can you see that on camera? I think you can. It's almost like spring steel. Putts. So, got here's a neat part that is used on this. This, I think it's this one. It's a MOSFET designed for batteries. So instead of the two FETs that are down here, you combine it into one, and it's a super small package. So I'm hoping it works nicely, because if it does, it's going to be my preference. Because it would save me a bunch of board space. There's that. And we're gonna need another one of these. Thank goodness for the quick standard. Makes things so much easier. Wish more companies would put it on their dev boards, to be honest. Especially if you're designing like a dev board for these various ICs, and it's not necessarily an MCU breakout. The other cool part that I've got is this here. It is a fuse. Now I'm not certain if it can blow on its own, but what it does have is an internal heater. So if the system detects a fault, it can cause the fuse to blow. But I'm not sure if it can act as a regular fuse, or if it does require the circuit to interact and cause it to blow. But either way, I think it's a neat IC. Now, other parts that I need. The wrong way around. Helps if I put the box the right way, I can actually read what's on the labels. There's one resistor I know I need. This is a diode, if I'm not mistaken. And RB, it's a really small one. Yeah, it's over here, and it's like super small. Buttons. MOSFETs. NTC on this board. $470 nanofards, yes. 100 picofards, I don't think is on this board. Nope. I don't think I have any LEDs on this board. Oh, I do have one. LED. No. That MOSFET is on here. 10UF. I don't think 10UF is used on here either. 22 ohms now. 53 now. Right. 150K. I think it's 150. Oh, that I'm looking for. I know one of these pots is listed as 1,000 picofarads, but I think I converted that. Yeah, I did. That's 1 nanofarad. Which is interesting, because if you go looking for that pot as 1,000 picofarads, it looks like a rare pot, and it's expensive. But you convert it to 1 nanofarad, and you can find it easily as a pot from suppliers. Yeah, 1,000. It's 1 nanofarad. Yeah, there's 10 nanofarads. That one is on the board as well. This has... I don't think this does have a sense resistor, does it? Oh, it does, yeah, it's the 5-inlay resistor. Well, there's the 1 nanofarad. I'm still looking for... what is it that I'm still looking for? Let's see. Still looking for, I think, 10 ohm. Yeah, so 100 ohm, 10 ohm, and 150 ohm. And then the 10K, oh yeah, 49.9. 100 nanofarads. 10K. 1K. 100 ohm, 10 ohm, there we go. It should be all the ports. Probably gonna start with the wheels first to get them off my bench, because they take up so much space. Okay, let's get some solder paste. Actually, there is one part missing, I think. That would be, this part is still missing. That uses a few of them, doesn't it? Let's see here. Did I find the 150 ohm? Got the 100 ohm. Got the 10 ohm. I do not have the 150 ohm. I'm still missing 3 parts. Let's see here. That's 150K. Oh, there it is. This is a bidirectional TVS diode for protecting, it protects a few spots from ESD. Although, when I build the actual device, I'm more than likely going to eliminate it, because it should, unlike a breakout board, you're not connecting and disconnecting things. And I did find the 150 ohm. I don't think I'm missing anything else. Granted, everything should be in this box, so it shouldn't be too hard to find things. If I am missing something. Probably because I have 144 subscribers. I'm not popular enough. But hi. Yeah. I try to mix up my hours sometimes, but I do tend to be a night owl, so I'm not normally awake very early, and if I am awake early, sometimes I'm still lethargic, so sometimes I go back and take a nap, yeah. Working on the BMS board, I did get the charger finished shortly after my stream yesterday that I had to end early, but it does work. It's charging at about 120 milliamps right out of the gate, and it responds to the I2C address, so that's a start. Just about to get this working. Oh, and the power delivery board, it works properly. The example code I found for it needs some work on error handling, but other than that, I'm going to convert that code into a library so that you can actually utilize it better. Now, normally for my streams, I try to post them both on Twitter, and haven't set up a bot to do it, but I manually post it on my announcements channel on my Discord, so. But I don't want to spam everywhere with what I'm working on. If I'm gonna grow an audience, I'd rather grow it for the work that I'm doing. Yeah, so the way the code works for that is so I tried it with a fast charger that I use for my phone and whatnot, so it can do 5 volts and 9 volts, and the code looks like it's supposed to say, like, if it can't negotiate power delivery, it's supposed to do something, but it doesn't seem to be doing anything. So I thought maybe this thing's broken, because it powers up and it responds to the I2C commands. So what I ended up doing is using one of the Arduino examples that tries to go through how to talk I2C. So I started pointing it at the register for the temp sensor on it, and sure enough, put my finger on it and the value starts changing how I would expect it to. So I'm like, okay, so it is working and it is communicating, but it won't let me turn it on. Now, I haven't checked to see if there's a command where you can actually ignore the fact that there's no power delivery and just have it send power. So I went out and bought a power supply and plug it in, and sure enough, it tells me all the options that are available from this particular supply, and I could select them and have it change. But I did notice that it has no way for you to tell it to turn off if you wanted it to turn off. So once you've told it what voltage you want, you're stuck with it delivering power. So, but at least it gives me a starting point. It's better than nothing. I think that's what they should do with a lot of ICs. Don't release it onto the market unless you can actually prove it works. If everyone has to spend $180 on your demo board, and the only way to interface with that board is through Windows machine and some Windows EXE, I think that's pretty darn silly. Or they end up using a PIC controller, which, PIC is used in environmental applications and stuff, but you don't see it much on the hobbyist level as much these days, I don't think. So, yeah. think I got everything. Saves me from having to scrape the crap out of these bigger blobs later when I go to clean this. The fun one to clean is always the QFN. My Twitter handle, yeah, I could post a link. Yeah, I don't have my Twitter handle as my business handle. It's probably one of my only social medias that isn't under my business name. Wonder if it would actually let me change that. I doubt it. Settings. Ah! Thank you, Johnny. Oh. Why is... This is what I hate with getting a new phone, is it changes all your notification settings and it says, now they're all gonna turn on. Let's go in. Oh, that's really annoying. This new phone, the old phone, it used to show you the most recent notifications and let you immediately change the settings for those particular apps. But now, you have to find the app manually and change it. There we go. I was gonna check. Hide it. Settings. My account. Account information. Username. Let's see. Nope, too long. Oh wait, hold on. Yeah, can't do Austin's Creations, of course. Oh well, I'll leave it. Okay. That actually pasted pretty darn well. Nice. Let's bring in the microscope camera. There we go. Is that max? Oh, let's max out the height on this. There. There we go. cables. Uh, 1K. No, there's one over here. I got two 1Ks that are larger size. Not that I'm actually... I know, like, the amount of current they actually expect to go through them is kind of low when you actually do the math on it, which is kind of silly. One of them actually will sink a fair amount, but the other one... They wanted a large resistor, but per the reference design, but it's not actually moving any current. I think it's just the one. Cool. Where to put my tweezers? Oh, there they are. See you later, Johnny. Thanks for popping in. This is 10K. There's quite a few of these. Let's start up here. There's one there. Oop. One. Should be one right there. Yeah, the one thing I do, I like a lit up LED, but I don't like overdriving it, and I do not need to be glaring out the eyeballs every time it lights up. So I tend to use a high resistance on them. There's another 10K over here. That goes there. And I think that's all of them. Although I thought there were more. Yeah. Appears to be all. Next, 100 nanofarads. There are a bunch of these all over. Oh, look at John go. From Superhouse TV, in case someone rewatches this and wonders who I'm talking about. Looks like some beams arrived for the Super Lab. Okay, 100 nanohertz. There is. I thought there was one up there. Looks like none there. The next one is right here. Again, I keep thinking there's more of these on this board than there actually are for some of these values. There's one over here. And there's two down here. No, not normally. I find this tends to be faster because the way my desk is shaped. Some of my most of my bigger screens are harder to see. I'm using my small one to keep YouTube chat visible from where I'm sitting. But on pretty much all these boards, I almost always use the value on the silk screen. So I tend to find it faster to place things that way. 49.9. There is a bunch of them. I think there's 4. Oh yeah. Yeah, if you're doing a large number per board, then yes. Thankfully, I haven't gotten that complicated. I think of my recent ones, this was the most annoying. This was the one I was working on yesterday. Not because it's actually here. Let's switch camera views. Not because it has a lot of parts, but at least for the main parts near the IC, they all have different values, and it's like only one of them. That kind of gets annoying. Having to pull out one of each part and place them. But for the most part, no, I don't have that big of a bill of materials. Ten nanofards. There's 4 in that corner, and I know there's a few others. There's one there. Wait, is this 1 or 10? 10, okay. 5 of these, I think. Thankfully, with these boards, I've been getting lucky. They've been working. Granted, following a reference schematic, so I kind of hope they'd work. 150 ohms. There's one up there. 2, 3. I got 3. Ooh, I dropped that somewhere. Actually fell into a through hole. Yes, they can be. This board here, the one I did yesterday, that one is a buck or boost. It adjusts based on what you're feeding it into, whatever size battery you're telling it you need to charge. The way I have it set up, it should be capable of doing 8 amps with the sense resistors that I used, but it offers the ability to use a different sense resistor and get up to 16 amps out of it, which I think is just absolutely absurd. Heck, I don't even need the 8 amps, but it's an I2C enabled chip and gives you monitoring capabilities and a wide input range, all that kind of stuff. So, and it will feed both the battery as well as your system voltage. So, but if your load is too high, then it will supplement your load with the battery, so you're not actually getting any charging out of it. I imagine, yeah, if you're trying to pump 8 amps through it, you'd definitely want cooling. But I think at most I'll be using an amp. All the parts are overrated for that. With some really big traces on it too. I didn't even use traces, I used fill on it. Big as I could fit for the area that I had. 470 nanofarads. There's 1, 2, 3. Oh yeah, that inductor was part of the recommend, because I followed the reference schematics. So that's the inductor for if you wanted the 16 amps. I just figured for a test run to see if these ICs will work for my application, it's probably just easiest and best to follow the reference schematic. The one I'm interested on this particular board is, so I have these two FETs set up for because it uses the blocking diodes in them because you can enable charging or discharging based on voltage protection limits. So one might be on while the other one's off, so current can flow in particular directions based on the blocking diodes and the MOSFETs. Well, in the reference, they point out this particular FET, which is like 3 by 3 millimeters. Now, the one they specifically mention is no longer made, but I found similar technology and pretty much matched the specs on it. And this thing is supposed to be more capable than these ones. But I'm very intrigued to see how it actually ends up performing. I have no intention of pushing it anywhere near its current limits, but if it works, I'm going to like it because of its size and the fact that I'm building something that's kind of small. See, I'm used to working on designs where I have the space, and I like reusing parts so that I don't have to keep inventory for half a dozen things. So normally I use I think they're SOT-sized FETs. Where are they? Oh, SOP 8. But in this case, I'm building something that needs batteries, and because I'm actually selling it to someone, I'd rather the device be kind of foolproof and not have issues, so I'm willing to spend the bigger bucks on good ICs that can do what I want, rather than your off-the-shelf battery management stuff that doesn't give you any information. Just either your battery's working or it's not, which is not very useful. Whereas with this, I'll be able to know how much power is left, and I can give you runtime statistics and all that kind of stuff. Is this thing directional? Can't tell. I think it is. It looks directional. Let's see. KiCad. Open. File. Open project. Schematic. That diode. Let's open the PCB view. Yep, It's directional, alright. So just load up the part number. Oh, this thing's apparently supposed to have a marking on it. That's gonna be fun. This is a SOD 923. Oh my goodness. I think this might be one of the smallest parts I've ever placed. Did I lose it already? Oh, goodness gracious. There we go. It does indeed have a marking. So the line goes that way, so I'm holding it the right direction for placing. Can't even see this darn thing with my eyes. Oh no. Stuck my tweezers. Darn it. Let's try that again. Oof. There we go. Why do I have this one? I don't think this one's used on here. Yeah. That's the wrong one. Thank you. Thank you, thank you. Let's place this. Hoping. Yeah, that's the right way. Wish they made these markings a little more visible. My goodness. It's got a little tiny dot on it, but it's so hard to see it. It really does depend on the light. I can agree with that. Big buttons. If I'm not mistaken, one of these buttons should be for jump starting it, telling it to turn on when it's fresh. Also for turning it on when you've put it in shipping mode. LED. I always forget which way this LED goes. So it doesn't have the standard, what do you call it? Markings that you normally see on small LEDs with the green line underneath them. It has a small copper trace on it on one of the pins to tell you which way it goes. I always forget which way that is. And not two LEDs tend to be the same, so which is always fun. I think the worst one I've had so far was the 5730 LEDs. Very bright LEDs, they work very well. But I've had them come reverse from the same supplier. So you're placing them all, and then you go to power up the device and find that one color of your LED is backwards, which is very annoying. 1, 2, 3. Yeah, 3. Yep. Gotten in the habit of trying to find more reputable suppliers for things, along with testing before soldering. Thankfully, the device it was on wasn't too hard to cut a trace and fix it, but it was still annoying. I think that's that. Yep. We have... Oh, I missed a capacitor over there. Right there, 470 nanofarads. Yeah, it really could. Plus, the 5730 LEDs tend to... Well, they're standard size and they're fairly common. But normally, the pads are laid out in a very particular way. And what's worse is you can't rotate the part because it has a pad underneath the LED. And if I'm not mistaken, that pad is supposed to be your positive. And it's off center, so you can't even rotate the LED to change the polarity because then your pads are wrong. So yeah, if that pad was centered and you could properly rotate it, then you'd be fine as a solution, but you can't. And yeah, normally that pad would be one particular orientation, so when it's backwards, it's not something you'd be expecting when that is not normal for that type of LED. One thing I wish they'd make more is the RGBW variants for the addressable LEDs. I mostly buy the 50/50 versions because they have the RGBW, and I tend to put them in something where having a dedicated white channel looks nicer than trying to mix a white. But sometimes it'd be nice to have a smaller version. I think I found a 3535 online. I haven't bought them to test. Let's make sure. This is 10 ohm. So at least one. Yeah, the other one's 100 ohm. Oh. Just placing that 10 ohm there. See you later, Inhuman. Thanks for joining. I need 470. Another vet. Channel fits, and let's see here. $170 nanofarads. Not officially, but I definitely do engineering. Not structural, but I do electronics stuff. I'm not a licensed engineer by any means. I'm an advanced hobbyist at best. This particular board is a battery BMS board, specifically for 2 to 4 cells. It's part of 5 boards that I've been working on for the past few live streams. So the past few live streams I've been working on all these boards. You have a USB-C power delivery board, you have the battery charger, you got a battery holder with some pins on it so you can select between testing a 2-cell setup or a 3-cell setup or a 4-cell setup. And then I also have a control board with a screen on it. It has a ESP32. You have your I2C quick standard connectors, so that you can interface with the various boards. And then the one I'm doing right now is this BMS board. Testing the individual ICs that each one uses for a potential project where I need to manage some batteries in it. But I haven't used these specific ICs before, so I'm making these boards to test them. Now, there's one part I haven't seen. Missing the diodes for that. Where? Let me double check my orders. Let me check my order printouts. Oh, that's why. It's in a different bin. There it is. I need 1, 2, 3, I think. Yep. If I'm not mistaken, these are also polarity sensitive. Yeah, they look like it. Let me pull up the spec sheet. It should have a marking on it, which I can slightly see, which is good. Just the fun task of getting it out of its packaging. There we go. At least this isn't as small as the other diode I had to place. And I could actually see them working on this. Which way? TTE? I don't think I've actually ever heard that before. Oh, the best solder paste? Oh, goodness. I have no clue. I am not a paste connoisseur by any means. I use your bargain bin eBay paste. It's leaded based, which you don't want to be using for production stuff. Beyond that, I have no clue. Come on. Ooh. Should still work. That leaves three oh no, I can place that connector. Missing that and two parts over here. Learning PCB design is always a fun task. Goodness knows I learn something new pretty much every time I design something. These boards are a good example of that. This is my first time following a reference diagram and trying to work with a brand new parts that I haven't worked with before. Normally I just reuse a lot of things that I've worked on. These are probably the most complicated ones I've had to work on and come up with new designs for. And the last part is the main IC. Oh, a patented design. I can't help you there. I open source all my stuff. Find it's not usually worth the cost and the hassle, and not many things are new these days. So, but I prefer open source. Unless you're being patient. Which, I have no idea. That should be all the parts. Time to go in the oven. Why open source? Because I find more innovation these days happens because of the open source community. And more often than not, like if I'm doing circuit boards or whatnot, like yeah, you can take the files and go get a fab house to produce it for you, but most people don't go through that effort. So either buy it from you, or they only want one, in which case they either buy it from you or they just buy one from a fabrication house. Whereas if like I haven't designed anything that's really worth anyone ripping off, well, I guess you could rip it off, but it hasn't been ripped off, and I'm not really in the position to mass produce anything anyways, so it doesn't bother me too much, at least. And if there's anything to learn, it's easier to do that when the files are available to people. Going to need to disconnect that. Let's see. Put a new cable in. Oh, almost put that cable in backwards. I would have let the smoke out. And I do not want that. I think I have an IDC cable already made. I do have a website. austenscreations.ca. Should be a long enough cable for testing at least. Should look. Probably make another one later. Cable. But 3 minutes left. 3 minutes. make sure this has the right program loaded. I think it does. I think it's a basic scanning sketch. Did that fail? Let's see, device manager. Well, that failed to load. Probably maxing out that USB hub. Let's see. Got a second cable underneath the rack. I have an oven that is running right now. It's a T962 oven. So I just put the solder paste on the circuit board and it takes care of the rest of it. Okay. Yep. It's all pretty much automatic. I bought it in college. I think I spent like $300 on it. Saves me so much time. I do have a hot air station as well, so I could manually do it with the hot air station as well. If you enlarge the pads, you can do it with a soldering iron, but that's really risky for tip leakage voltage from a soldering iron, which can destroy parts sometimes. And then the other problem is overheating a part with a soldering iron. So the oven is easiest and most straightforward thing, and the cycle on the oven takes about 7 minutes. Yeah, it's not the largest oven and it's not the absolute perfect oven, but for what I do it looks fantastic. What am I missing? Parts. Let's see here. I need that. Those. One other thing I know I'm missing. Let's see what it's For the most part, it just depends on what parts you're using. I haven't had, I've only had one part that I got close to burning, because it was a low temp part and I didn't realize. But you can adjust the profile of heating curve on an oven so that you don't burn parts, and then you would potentially use different solder paste to match that temperature profile. If you had to adjust it a lot, you'd probably use low temp solder paste. Where is that part? Must be in one of these boxes. Using it the other day. I've seen it. This is annoying. Should be in a large enough bag that I don't miss it, but where? But that's done. The part I'm looking for is this part over here. I'm not finding it. Unplug that for now. Let that cool off a bit. One, two. Need two of those. Need to figure out where I put those parts. Yes, they are 2.54. And in this case, oh, I should probably turn on my soldering iron. This case, let's see here. I'm moving one of the pins on these because I'm actually using it for selecting. And that pin is not needed. Oh, the bag was in front of me this entire time. There's that pipe. This one here. 1, 2, and 3. See if my soldering iron's warm enough. It is, but before I start soldering, let's double check and see how this turned out. Let's see. Oh, look at that. That's just beautiful. Well, yeah, that's soldered. Yeah. What? Yeah. Oh, yep, that worked. Not soldered properly. That one right there. I'm wondering if that's soldered properly or not. I think it did. But that's a fair amount of solder on the other side, but looks good. So I will use it. Oh yeah, a lot of these chips are very small indeed, but they tend to solder fairly well, which is good. Makes it easy when things solder nicely. And let's go back to that. Okay, let's get these parts in place. There's that. This one, the reason for that is because I had the resistors and capacitors here. So to make running traces easier, I just put the connector in further. it stands out a fair distance. But if, like, I could get this as close as I pretty much want to the edge. Mostly what factors into how close something can be is the copper distance. Normally I set at least a half a millimeter to a millimeter on the board edge. Just prevents issues. But a lot of fabrication houses have very tight tolerances for a lot of things, so it mostly just comes down to preference and design requirements. But if I have the distance available, I like to use it. Oh, I could go much closer. I'm not producing my own boards. I get a house and I use JLC PCB to make the circuit boards. So I could go much tighter if I wanted to. I just chose not to. There we go. Well, you can do multiple layers on a board. The physical separation is just the fiberglass of the circuit board. That is some good lemonade. Okay. yeah, that's done. Now, I want to... Let's put it this way. Some connectors. Ooh, that is one tight screw. That goes to that connection. I'll definitely have to make a longer cable at some point. And then, where is it? Not that board, but this board plugs into there. And I'm gonna connect my multimeter to the output. I think the multimeter fits or not. It does not. Okay. What I can do is I have some copper wire. And we'll swap out my multimeter leads. Yes, I'm about to test this. Ground goes to that one, positive to that one. And turn on the multimeter. Oh, go. And then let's see. is on and working. So let's see. Okay. So it isn't showing this board in code right now. I can show you what I'm running. So it's running a scanning sketch right now. So hopefully when that board powers up, I should be able to see something. And obviously, for it to power up, I need some lithium batteries. So I can put some batteries in, and I should be able to put the jumper in place. So it's showing a small amount of power. I don't think it's fully turned on. Hoping pushing the button should cause something to happen. It did. There's very little output voltage, so I don't think the output is on, but the actual IC is in fact turned on. Although the interesting thing is it seems to have two different addresses. So it shows up as 0x36 and 0B. It's definitely interesting to see that it is working. Oh, it did turn on the output. I just noticed. So it is actually working. So it took a moment for it to properly turn on, which is cool. I have no idea what this other button is for. Curious if it would actually do anything, but pushing it doesn't seem to change anything. Does it turn back off if I push the button again? I don't think it does. But the board is working. Hooray! So I'll have to look at the spec sheet and figure out why it shows up as two addresses. Unless it's got that many settings that you need two addresses, but that is X36. So normally when I'm programming, I use VS Code with Platform IO, and I'll use the Arduino environment coding language. For this particular thing, I'm just running using Arduino IDE to run their I2C scanning sketch. Obviously I can easily open this in VS Code if I wanted to, but it's easy for me to open it in Arduino because it's typically the only one I use for this sketch. And all it's doing is it's trying the various addresses. I think there's like 127 of them. And it waits to see if it gets a response. And that's how it knows an address. And if it's having an issue getting response because more than one device has that same address, it would throw an error. But that's how I know there's a device with a specific address. But it's the only device connected, but it's giving two addresses back. So I know, like, I have an LED controller, and that controller can talk to two different addresses. One of those addresses is considered an all-call address. So if you had more than one of that chip on the bus, and you wanted, like, say, all of them to turn off, instead of sending a command to each of the addresses, you could use that one address to say off, and they would all listen to it. So there's various reasons why it might have two. Let's see. Let's disconnect that. And I'm going to disconnect that. It should turn off. Weird that it's still trying to stay powered. How can I do this safely without shorting anything? There. Oh, it's still trying to stay powered. I'm wondering if I reconnect power, does it stay alive? Ah, so it's off again. Cool. So if I hit the button, it should come back online. It's not really low power level. Should be higher than that. Ah, there we go. Nope. So this is a bypass, which is why the voltage jumps up, but I'm not seeing it turn on. Let's see here. Disconnect. And then, let's see, does that turn it back on again? It's coming on very, very, very slow. I'd expect it to, oh, I think I know why. I think it's the pre-charge. So instead of immediately turning itself on, it's gonna go really slowly in an effort to protect everything. If I press and hold that, yeah, see, press and hold it and I can speed that up so that it actually turns on. There we go. Cool. I just wanted to make sure that it would actually work properly and respond. Yeah, I'll leave that in place. Okay, so let's disconnect this and turn everything off. these cables in place. The batteries are out. And the other one that properly works is this board. No, not that board. This board. This is the power delivery board. This one I have both working code, but which will need some work to make it fully useful, but it at least lets me test it. So, if connect it, and I'm going to upload the code. And then I do sell some of my boards. Depends what it is and if I can get parts for it or not, but I do sell them from time to time. Okay, so I have the console open. Right now, because the board isn't powered, it won't do anything. But so I initially tried using a normal USB power supply, fast charger, and it does power up the board. And you'll see a status LED just blinks. So the problem with the code that I currently have is it won't actually work. So I'll have to fix that. But if instead I plug in this cord, why is that not turning on? It's very weird. This was tested. Come on. No, the code isn't doing anything right now. It won't do anything until I tell it to. I have to send a command, and it's disconnected at the moment. Because if I switch to this supply, it will turn back on. Since the power supply not turning on properly. I'm just gonna try something. I don't expect it to work. Nope. Let's see. Oh, I know why. I accidentally turned my power bar off. That's why. Can't work without actual power, but it's lit up now, and you'll notice the status light is not blinking anymore. And if I go to the serial monitor and I tell it to run, so with the other fast supply, it will not actually, it will say starting test, but it won't run everything after it. It won't run this. So there's a problem with the error handling in the code. But it tells me the supply I'm connected to has a 5 volt at 3 amp, 9 volt at 2 amp, 12 volt at 1.5 amps, 12 volts at 1.5 amps, 15 volts at 1.2 amps, which is correct. It's identifying all the proper options. This particular IC is compatible with 20 volt power delivery, as well as the power delivery where you can select anything from 3.3 volts all the way up to 20 volts. Some power delivery supplies you can actually set a dynamic range instead of these ones which are all fixed. So if I so right now there's nothing on my multimeter, but if I tell it to start number 1, I now have 5 volts available on the output here. And I can switch it. So now there's 9 volts. Let's go to 3. There's now 12 volts. And I can do it again. I go to 4. Now I have 15 volts. So, yeah. It does indeed work, which is pretty darn awesome. And when it's turned on, it lights up the LED here. Very dim LED because I have a high value resistor, but it does turn it on, and it's steady, unlike when it's on the other charger where it blinks because it knows there's an error. So the only thing now is to write some better code for it all so that I can actually use the boards in conjunction with each other. Yeah. I'm happy that they pretty much all work, which is nice. Well, think that's all my streaming for tonight. I have all the boards done, and it's gonna take me a while to put code together for them, to actually put them through their paces. Oh, you're very welcome, Stephen. I will hopefully have code in a few days, maybe longer, because I kind of have to be in the mood to really sit there and code. I can do code, but it will take me a while, even more so if I'm not in the zone. But I do have parts that I'm still waiting for, so hopefully some parts show up and be able to talk more about the project and show off some of my prototyping and testing as I make my way along. And then once I have all these boards working, because the bonus of how I've set them all up is they're all designed to plug into each other. So this one plugs into this. Yeah. Let me unplug things because I don't want things to short. Do plug that, unplug that. So the way this is all set up, I grab some cables. Let's see here. So this would plug in like so. Nope, that's backwards. And then the board, this board here. So undo the screw terminals. And I've set them all up so that the polarity on them allows the cables to move nicely and you're not bunching them up and twisting them and everything. I'll probably make some sort of a backer board so that I can screw them all down nicely. But this one, so this is your battery connection, so it will connect depends on what you're doing. I'm mostly selling these, well, not these particular boards. I don't really plan on selling these ones, but most of the things I've sold are DC low voltage, and they're sold as is. so they don't have certification and don't tend to need it, but it can depend who you're selling to and what you're selling. That connects like that, and then one last connection. Actually, here's a test that I can run. If I like that. These cables are big cables, so they go kind of all over the place. I'm going to get my USB cable. And run new program. Grab a few cables. Disconnect that. Connect this to there. And need one more cable. I really need some more large cables. I had ordered large cables, but I didn't pay attention to the listing where they have chopped ends, so I'm gonna have to solder them later. I'll probably do that once I have a board to put these on, so that it's not a jumble of wires everywhere. Right. Nope, this way. This cable is on the last one. Combination. So I wanted to make sure that these ICs would work for what I want them to do. But I also need to know that I can make code to make them work. So this will let me test both of those aspects, and then the devices I'm testing these for, I'll be able to design those circuit boards and make those down the line. Still waiting for a few parts to show up so that I can test test them, and then I'll be able to finalize the design. I'm building an inventory management system. Right now, so I'm building custom barcode scanners, and those scanners need batteries to operate. So that's why I'm working with these boards right now, because they will let me test batteries. So, if I put the batteries in, absolutely nothing should happen. Ta-da! Nothing. I'm gonna plug in the power delivery so that it turns on, but I'm not running the code for it, so it's not powering the charger board or anything else. And the main control board is still turned off, but if I push the button on here, it does in fact turn on. So this system is now working, and if I connect USB, I can see that I have USB power, so I know the USB is working. And what I should be able to do is run a sketch, and it's running. So this is your I2C scanning sketch, and it's finding 4 addresses. The BMS board has 2 addresses, but it's finding the other 2 as well. So everything is currently working. So, hooray! I think it's pretty darn awesome. And then if I wanted to power something, when designing these boards, because I'm using all the connections on the board to properly interlink them all, I've left 2 extra spots here, so if I wanted to hook something up, I could connect to something. But it's not switched, so you don't have any control over it. But if you wanted to, you could design it so that this could control an output to something. But the other option with I think the BMS chip is you can put it in a shipping mode, so it'd be wired like this, but you could turn it off, and then to turn it on you would have to provide power to it. Either you'd have to program the PD chip to automatically select a voltage and turn itself on or whatever, but in the case of my barcode scanners, I'm not actually going to use the power delivery chip. It was just a chip that I think I can use in other projects, and I kind of wanted a whole suite of items that can work together. That's why I have it. But I will be using the charger chip, and the charging chip I can just connect to a 12-volt power supply without any issues. But I figured I'd test everything all at once. So, hooray! But that would mark the actual end of my live stream. Unless there's any other questions. some sort of... I have something that I can mount these on. And I'll just mount them up. Probably something like that. Ideally, I'd have this one like this, but it's taking up so much space. Bigger than... I have done some live streams in the past. I'll probably do more at some point. It's been a while. Yeah. That's probably the way to do it. It's gonna be doing it like this. Yeah, that makes sense. Yeah. It's probably how I'm gonna lay out a piece of wood so that I can screw all of these in place. Yeah, but that's it for this. So have a good night, folks, or time zone appropriate response.